All right, pre-calculus students, we are back talking about 6.1 on vectors. Hopefully you got the first assignment done and you have an idea now of how to find the components of a vector. If you are given the 2 points A and, or I'm sorry, the initial point and the terminal point, you can find the components of the vector. And remember, every vector is defined by two things, a direction and a magnitude. Okay, so uh, now we want to talk about finding the components of a vector. All right, what if you know the angle and the direction? Can you break it down into x and y components? All right, and we're going to be doing a lot of this in when we get to application problems next. I'm going to give you a direction and a magnitude. For example, let's say a ship is sailing at this direction with this velocity, with this speed. Um, or a force is being pushed up a ramp at this angle with this amount of force. Things like that. Those are all vectors. So let's draw a vector here in quadrant 1. Doesn't have to be in quadrant 1, but let's call that our vector v. Okay, and we want to find the component form. We want to find the a and the b. Okay, so let's say that we know two things. We know the angle theta, and we're always going to measure our angles just like we do on our unit circle, starting from the positive x-axis and rotating counterclockwise. So we know theta, and we know the magnitude of v, which is the length of that arrow. So you are given a vector, you know the magnitude and the direction angle. You want to find the component forms, a and b. Well, what you're really doing is you're really making a right triangle, aren't you? Right? If I were to draw a right triangle like this is the horizontal component, so this is A, and this is the vertical component, so this is B. Okay, so this is where the trigonometry comes into play. We're just going to use the right triangle trig that you have already done before. All right, so let's say you wanted to find A. Well, look at this right triangle. You know the hypotenuse and the angle. You want to find the adjacent side. So I'm going to use cosine. I'm going to say that cosine of theta is adjacent over the hypotenuse. And I can multiply and solve for A. I can say that A is the magnitude of velocity times the cosine of theta. All right, let's do the same thing to solve for B now. B is the opposite side. So if I have the opposite side in the magnitude, which is hypotenuse, opposite hypotenuse uses the sine. So I'm going to set up another right triangle trig ratio and say sine of theta is opposite over the hypotenuse. So once again, solve for B multiplied by magnitude of V. So B is going to be magnitude of V times the sine of theta. All right, so now we can find the a and the b in component form. So if we're given a vector v that has direction angle theta, then the component form is the x component, or the horizontal component, is the magnitude of v times the cosine of theta, and the y component, or the vertical component, is the magnitude of v times the sine of theta. Okay, so that should be pretty easy to remember. Just magnitude cosine theta, magnitude sine theta. All right, and remember back to the unit circle. Remember on the unit circle, the x component always went with cosine, and the y coordinate went with sine. Same thing here. Cosine goes with x, sine goes with y. Right. So that's why I said it should be easy to remember that. I hope. So we're going to be using this a lot in the future. So here's an easy example. You'll want a calculator for this to check the calculations yourself. Find the vector v with a direction angle 130 and magnitude of 8. First off, let's draw the vector. Let's draw. I think it's always a good idea to draw the vector and visualize. So you can see what quadrant it's in, and you can see should it be more in the x direction, more in the y direction. Make sure your answer always matches up. So let's draw 130 degrees. Well, this is 90, and this is 180. So 130 is going to be right here, a little bit closer to 90 than 180, but not much. So that angle is 130, and the magnitude is 8. All right, so let's find the component form. According to what we said above, it's going to be magnitude times the cosine of v of angle. So 8 cosine 130, and then 8 sine 130. All right, and type those in your calculator. Now make sure you're in degree mode, right? Because those angles are in degrees. Make sure your calculator is in degree mode. And you get that the x component is approximately negative 5.14, and the y component is approximately 6.13. Two decimal places are good enough here unless it states otherwise. So there you go. There's your vector, negative 5.14, comma 6.13. Now, this is why I said draw the vector. Every time you do this, boys and girls, look at the vector and then look at the components and look at the vector. Make sure they match up. So many times, kids, you can recognize a mistake and correct your mistake because you can see that the values here don't match up with the picture. My vector is going to the left and up. So it's pretty clear x should be negative, y should be positive. X should be negative, y should be positive. There you go. Okay, so now I know how to find the a and the b given the magnitude and the direction angle. All right, there's one more thing I have to do now. Find the direction angle. So the last time we already did the magnitude, right? You already know if you know A and B, you can find the magnitude. And now we know if you know the magnitude of the angle, we can find A and B. The one thing we haven't done yet is given A and B, how do I find the theta, the direction angle? Okay, but once again, we're gonna use this picture here. We have a right triangle. Um, what if you know A and B? How do I find theta? Well, since I'm using the opposite and the adjacent, I'm gonna use the tangent. I'm gonna say that tangent theta is B over A, or if I solve for theta, I'm gonna use the inverse tangent. So I'm gonna say that theta is the inverse tangent of B over A. So if I'm given a vector V in component form AB, the angle theta is inverse tangent B over A. Okay, now there's a problem with this. All right, think back to when we did inverse trig functions back in chapter 4. Remember, each inverse trig function is only, the range is only in 2 of the 4 quadrants, okay? Um, inverse tangent, um, if you think back to unit circle for a moment here, remember, inverse tangent was on the right half of the circle, which means the answer was always between negative pi over 2 and pi over 2, right? It was in quadrants 1 and 4. And in quadrant 4 gave you the negative angle, not the positive angle back. So come back to here. Um, what if my angle is in quadrants 2 or 3? Inverse tangent will never ever give you an angle in quadrant 2 or 3. If you do inverse tangent on your calculator, it will never give you an angle in quadrant 2 or 3. It'll always give you an angle in quadrant 1 or 4. Okay, well, what do I do? What if I'm in um, quadrant 1 and I want to move to quadrant 3? Or if I'm quadrant 4, I want to move to quadrant 2. You want to move halfway around the circle. I want to move exactly halfway around the circle. So um, if your angle's in quadrant 2 or 3, then you must add 180 degrees. Sorry. If it's in quadrant 2 or 3, you must add 180 degrees because you want to go exactly halfway around the circle. And when we get to an example, I'll draw a vector, then hopefully you can visualize what we're talking about, why that's true. Okay. Um, But the reason is, again, let's say your vector is supposed to be here in quadrant 3. It'll actually, when you do inverse tangent, it'll give you an angle here in quadrant 1. So you have to add 180 to go halfway around the circle to get the correct angle, right? And likewise, if it's supposed to be in quadrant 2, it'll give you a vector in angle in quadrant 4. You have to add 180 to go halfway around the circle. All right. Now, if your angle's in quadrant 4, it will give you the correct angle, but it will be negative, right? Remember, it'll be going backwards, it'll be negative. Okay. So if I want a positive angle instead of a negative angle, this time I don't want to go halfway around the circle. I want to go all the way around the circle. So I'm going to add 360 degrees. Okay, and again, think why. If my angle is supposed to be in quadrant 4, let's say it gave me an angle, it would be the correct angle. It would only be negative, but I want to make it positive. So I want to go all the way around the circle as a positive angle. So I want to add 360 to make the angle positive. Okay, so when you're solving for an angle, okay, you always draw the picture, always draw the vector to see what quadrant it's in. And remember, if it's in quadrant 1, you're good. If it's in quadrant 2 or 3, you have to add 180 to get the correct angle. If it's in quadrant 4, your angle's negative, and that's correct, but if it asks for a positive angle, you have to add 360 to make it positive. Okay, so let's do those two examples now. Here, I'm going to give you a vector, draw the vector, and then let's find the magnitude and the direction angle. And again, always draw the vector first. I want to see you draw the vector to help you visualize what's going on. So let's draw the vector 5, -2. So that's going to be in quadrant 4, right? Because we're going right and down. So 1, 2, 3, 4, 5, 1, 2. Remember, the standard form of a vector always starts at origin and goes from there. So I'm going to the right 5 and down 2. That is my vector. Okay. So first thing, find the magnitude of that vector. All right, that's what we did on the last video, right? That's just the square root of a squared plus b squared. Pythagorean theorem. So it's just the square root of 5 squared plus -2 squared. So it's the square root of 29. Okay. And if you want to get a decimal approximation, that is about 5.39. Okay. Now, so that was the old problem. New part. Let's find the theta. Let's find the angle here. Okay. So we're going to do the inverse tangent of b over a. So -2 over 5. Okay, and you do that in your calculator. Again, make sure you're in degree mode, and you'll get -21.8 degrees. All right, which is not wrong, but it gives you this angle. I want this angle. We like our answers to be positive usually. I want to find that angle, theta. Okay, so since I'm going to go all the way around the circle, I'm going to add 360, and I'm going to get that theta is approximately 338. 0.2 degrees. Okay. And now double check yourself. Look at that picture. Is that angle in quadrant 4? Yes, it is. Does that seem like a reasonable answer? Yeah, I hope it does. That angle there is 338.2 degrees. Okay. Um, Now let me go back for a second to this. I think you can see why you have to add 180 to if you're in quadrant 2 or 3, because look at this. Suppose that this vector, instead of being 5, -2, suppose it was -5, 2. So it would be the same vector just in the quadrant uh, 2. If you're going backwards, left 5 up 2. But when you type this in your calculator, inverse tangent of 2 over -5 is the same as -2 over 5, right? When you do -2/5 in your calculator, it doesn't know if the negative was on the 2 or the 5, okay? So it's going to give you the same answer whether you're in quadrant 4 or quadrant 2. It'll give the exact same answer. So that's why if you're in quadrant 2 or 3, you have to add 180 to distinguish which you're talking about there. All right. Let's do one more example, B. Let's draw -3, -4. Okay, that's going to be in quadrant 3 here. So to the left 3 and down 4. Okay, so again, when I want to find my angle, I want to find that angle, theta, always measured in the positive direction from 0. Okay, so first thing I want to do is the magnitude of V. Okay, square root of -3 squared plus -4 squared. Okay. Or if you remember from geometry, that's just a 3, 4, 5 triangle, right? 3, 4, 5 is the right triangle, so that's just square root of 25, which is 5. Okay, now let me find the angle. Theta is going to be the inverse tangent of b over a, so -4 over -3. Okay, do that in your calculator. Okay, but notice the two negatives will cancel. That's the same as inverse tangent of 4/3, positive 4 over 3. So you can see, like I was talking about the last example, it doesn't know if you're talking about the vector 3 comma 4 or -3 -4, right? The fraction is the same both ways. So that's why, since this is in quadrant 3, you have to add 180, right? And you know that's true because look at what's going to give you as an answer. It's going to give you 53.1 degrees. Okay. Look at your picture. You know right away that's not correct. 53.1 is in quadrant 1. This angle is supposed to be in quadrant 3, right? So you have to add 180 to that and get 233.1. Sorry, that's a 1. 233.1 degrees. Okay. Now, look at that angle. Does that make sense? Yes, it does. 233 is between 180 and 270. That's in quadrant 3, so it's correct. So it's really, really important for you to draw these vectors. And when you get an answer, always make sure to look at the picture and see, does your angle match up with what quadrant it's in? If it doesn't, then you remember that you either have to add 180 if you're in 2 or 3, or if it's negative in quadrant 4, you want to make it positive again, you add 360. All right, so that is your next homework assignment, is going to be these two things: finding the component form of a vector and finding the direction angle. Okay. Our last topic, we're going to get into application problems. And these are often where it gets most challenging because you have to like draw a picture. We have different vectors added together. So we'll do examples of that in the next video lesson. Okay. So it's really, really important though to have these basic ideas and basic concepts of vectors down and know those well before you move on to the application problems. Okay. So um, the homework for after you complete watching this video, the homework is going to be, let me double check here. It is page 456 of your book. You can do problems 30 through 36 and 45 through 46. Okay, so try those in your book. And as always, when you're done, share your answers with me through email and I will check them for you.